Hello everyone, welcome to my channel, and in this video I am going to talk about the effects of fire on mine ventilation system, as well as I have given so many talks regarding the mine ventilation system in the previous video. I will give you the description box the link of those videos. You can see and go through the link and those video. You can also visit a underground mine, coal mine, whatever I will give you in the description box link. Okay, so let's start with the effects of the fire on mine maintenance system. You know, this is the gallery. Here it is shown that is less than 2.1 meter height, and that is the 2.4 meter width, and after 5 meter there is a sliding door, and it is a brick stopping. Here this is also a brick stopping of 2 meter range. Here also 3 meter here is given, and the sliding door is also here. And from the rolling shutter is also here, and that is the fan rip for the chimney here, and the return airways gone through that air. Okay, so this is the mainly the return airways, and chimney is here, and the fan is here, main ventilation fan is here. You know that in first video I told that if it is sucks one place, and the other places will automatically, the air of the other places will automatically go through that circuit or the airways, and you will be enriched with your working place with the best working airways. Okay, so simulation of open fire in a mine gallery under varied airflow for suppression of fire and explosion in underground coal mine has been given here. And you know that is the, I think I described earlier, and the most important thing, the elements of the setup. You see first that experimental gallery here is mentioned, and the gases analyzer are here, various gases analyzer, as because there may be a carbon monoxide, there may be carbon dioxide, there may be methane CH4, there may be C2H2, there may be oxygen percentage, there may be N2 percentage, there may be H2S percentage, there may be SO2 percentage, there may be hydrogen percentage as other any other hydrocarbon. So here you can see that electrical cables are laying in this way, as because if it is a underground mine there should be electrical cables. And the inner view of the gallery here by this, you know that is the fan here, and it sucks air from that those galleries portion here, and you know it sucks, and that length cross sectional area is 5.86 meters square. Generally it is here it is given, as well as that it is mentioned throughout the mine also, because this is basically a tunnel. And you know that if it is sucks one place and from any other intake airways, the air automatically gone through the mine, and it ventilates the all and every each and every places of the mine. And the shape is arc type, as because arc type means there may be a concreting over the roof, and you know that base is 2.4 meter, and crown height means total height of that arch type is 2.7 meter, and the gallery height is 2.1 meter. So that portion of arch is that 0.6 meter is the height. You know that is the most important thing, whatever I have shown in this chapter, that elements of the setup. Here it is given that view of the coal layer and the temperature sensors are also hereby there, as because the electrical cable panel as well as the electronics cable, as I mean the communication systems, will be properly implemented and given and properly set up in this video. Okay, so you know that the sensor hereby given that CO2, O2, CO and CH4 and H2 sensor, that is the sample out, and the cooler 1, cooler 2, cooler 3 will be there. This is basically instrumentation setup of a monitoring system. And you know that is there is a ceramic filter is there, that is also there. This is the gallery and the data logger here by here, and you know that each and every data will go through that data logger, and it output you will get your main computer or the monitoring room. So flow meter will also be there, and a diaphragm pump is there for the monitoring system, and the sample out is hereby given, and the filter and the gas flow rate will be determined here. So you know that it is the most important, as well as the partial telemonitoring system, environmental telemonitoring system, ETMS. That is the most important things to be understand for each and every places. That data logger will be there, and the 5 gases are also there, and the gallery and the ceramic filter will be also important thing to main output of the computer at the monitoring room. Okay, so parameter will be studies the temperature at 98 point, whatever I made during our study, and the concentration of the gases is CO2, O2, CO, CH4 and hydrogen, that is oxygen, carbon monoxide, carbon dioxide, methane and the hydrogen percentage at the 5 locations I have taken, and airflow rate at the entry of the gallery, and the pressure differential across the fire zone and the fan pressure hereby also be mentioned here. That is the most important thing. I told you several times that the fire zone, fan pressure as well as the pressure difference is the most important thing, and the smoke concentration density you may take, that is the another thing is this, that is a smoke means there is no dilution of air. If you flow the air, then every air will be dilute and no CO2, no CH4, no CO will be there. So there is a smoke means there is a chances of CO, and carbon dioxide is also there, hydrogen may be also there, and others carbon hydrocarbons are also there. Okay, means methane, ethylene, ethane, acetylene, etc. So effects of fire on ventilation, this is the most important slide, please note down this. And open fire causes a sharp increase of the temperature of the air. You know that if it is a fire, then there is obviously a increase in temperature, and the resulting expansion of the air produces two distinct effects. First of all, the expansion attempts that take place in both directions along the airway, as because it will spread through the airways, both intake and return. Okay, the tendency to expand against the prevailing direction produces a reduction in the airflow. This is known as the choke as throttle effect. You know that is the choke there will be there if it is a flow through return as well as the intake. Okay, secondly, the decreased density results in the heated air becoming more buoyant, and the causes the product of combustion, POC, to move upwards and flow against the direction of the airflow again along the rope. So you know that the product of the combustion means the most important term I have used here by also, that decreased density result the heated air becoming more buoyant, and the causes the products of the combustion, okay, so to move upwards and flow against the direction of the airflow. This phenomena also known as the black glass. I told in the first slide that what is direct blast and black glass. Okay, thank you, best of luck. If you like this video, please like, share, comment and subscribe to my channel. If you have any question, please ask me in the comment box. Okay, and don't forget to subscribe and don't forget to press the bell icon for the next video and next immovable video. Okay, thank you.